everyone, welcome back to another video of the data science series. In this video, we will be seeing what is data preparation phase to model the data. As we all know, data preparation is critical step in the analysis process, especially when preparing the data for the modeling purposes. It involves cleaning, consistent, and make data consistent for better analysis. But in this video, we will be discussing what are the phases to model the data. First, partitioning the data. The concept of partitioning the data involves splitting data into sets or testing sets, which is used to train models, and while testing set is used to evaluate its performance. This step ensures the data is correctly partitioned for better analysis purpose and unbiased evaluation, so the data can be processed swiftly in analysis phase. The another key step is to balance the training data set. The balancing of the training data set is crucial when dealing with imbalanced classes. For example, we used SMOT, synthetic minority over sampling technique, to generate synthetic samples for the minority class. This step ensures that each step or each class, uh, each model, the model learns equally from all the classes. We will be further seeing the example of all the key steps in code example. Build cart decision. Cart, also known as classification and regression trees, is a tree algorithm that splits data into subsets based on the feature the and the algorithm provides best splits. It uses Gini impurity or entropy to measure the quality of the split. By Gini impurity, we can measure how good a split is and make decision based on it, based on the quality of the split. Build C 5.0 decision tree. So what is C 5.0 decision trees? A C 5.0 is an advanced version or improvement over C 4.5 algorithm over the original ID3 algorithm. This algorithm uses entropy to split based on the quality of data and can handle both categorical and continuous data. For example, categorical data is based on class, and continuous data is like customer sales and etc. We will be further seeing the code example. Build random forest. Now, what is random forest? By random forest, we mean algorithm. The random forest is a machine learning algorithm which builds multiple trees, combines their predictions. It reduces overfitting, or the overfitting means too too much improvement of data to its inaccuracy. By this, it improves accuracy of our data and averaging in resulting trees. Now, after the code example, we will be seeing what are the benefits of each steps. So let's go to the code example. Okay, so here is the code example. We will be including the following libraries: pandas and sklearn and imblearn, and from that we have imported many more library. From pandas, we have included whole, and from sklearn, we have imported terrain test split. It is to split our model, and decision tree classifier. It is to make decision trees and classify the decision tree based on its performance. And import random forest classifier. It is to make random forest tree as discussed previously, and imported smooth way as we have discussed previously, and classification report and accuracy score from metrics of sklearn library. So here are sample data. Let me zoom into that. So here's our sample data. We have defined a data frame in which we are considering feature 1, feature 2 and target features. So we have defined the data frame, and we have created two partition of the data. Partition 1 includes feature 1 and feature 2, and partition 2 includes, or y-axis includes, target. So we have created xtrain, xtest, ytest, train or ytest to train the splits of the data. So we have successfully partitioned the data and tested the split. Now balance the training data set. We are balancing the training data sets using, as discussed, smooth technique, in which we are random state equals to 42 and k neighbors is, we have defined k neighbors or k mean neighbors as 1. So this is, we have a function called feed resample. It will resample the following data as we define in the first step: x train and y train. Now, after the successfully balancing the data set, we will build card decision tree. As we discussed, we will be building card 5.0 decision tree. First, we have to initialize card model. Again, random state 42 in cart model dot fit x trend balance and then y trend balance. The x trend and y trend balance we have obtained for resampling or balancing the training data. As you can see in the second step. Okay, y prediction of data, we have created a variable y pred data, y pred cart, in which we have included the cart model prediction. Now we are printing the decision tree based on the prediction of cart 5.0 algorithm and classify report according to it, and printing the accuracy according to x test and y test or prediction cart test. As we can see in the output, cart decision tree prediction results. The support is 0, 1, 2, 3, 3, 3, and the precision is 0%, so we can call it off. Now let's look at the card or C 5.0 decision tree, which we built in the following fourth step. Now C50 or C 5.0 model decision tree classifier, we have created a decision tree based on criterion of entropy, unlike 4.5 model. You can better understand if you research about the C 4.0 4.5 model. So let's take a look. There is a model C50. We have given the trained data, the trained balance data which we have given in previous step, and we are including it in C 5.0, so we can better understand the data for analysis purpose. So in this step, we can see we are predicting the X test which we have already obtained from this step. Okay, so we have successfully created C 5.0 decision tree. Now we have to classify based on accuracy or print accuracy based on it. By accuracy score function of sklearn or in classified report function. As we can see, C 5.0 tree results. Again, the support is same, but the moving average or macro weighted average is 0. So we can reject that, or the accuracy is 0. So let me show you. Again, our data was based on 0th or 0 accuracy. We can give any other data or based on large data sets. Now build random forest. We have to build random forest in Python. We have to create random forest. It is a predefined function or function in sklearn library. So we can see here we have initialized our variable called random forest, and we have inside that we have stored the random forest classifier function, the return value of random forest classifier and random state to 42. Now random forest model.fit. We have a function called fit in random forest or sklearn library. So we can fit the X and Y trained model based on that. As we can see there we have value of X trained and Y trained balanced value, which we obtained from step number 2 from balancing the balancing the data set after the splitting step. Now Y prediction. Now in this we are giving X prediction predicted value of X test to the Y prediction RF or random forest variable. So by these three steps we have successfully created a random forest tree by which we will further discuss the benefit of these steps after the code sample output. And again, as shown in same steps, we have again printed the accuracy score of X and Y. Here I have given Y to both because I have stored the return value of X test to Y prediction of random forest. Now as you can see, random forest results again 0 because the data set's precision is random, and same we are obtaining the same results. Now, what are the benefits of this step in data preparation? Of each step. After partitioning the data, ensures that the model is trained and tested on different subsets of data provided. In simple, uh, in simple step, we have splitted the or partitioned the data into smaller subsets of the data, providing unbiased evaluation of the model's performance. Now, after balancing the training data, we have addressed the imbalance of the each class and correctly classify minority class, and as discussed in previous steps, we are that model is trained on each class rather than focusing or unbiased evaluation of a single class. Now, after building the card decision tree, it provides a simple and interpretable model for classification tasks. And after building the card decision tree, we can easily build CART or C 5.0 decision tree, which offers an alternative decision tree algorithm that can handle more complex decision boundary or decision tasks. This, in simple words, after building CART decision tree and C 5.0 decision tree, we can offer alternative or many decision tree to handle more complex tasks. Now, after this, we have to the benefit of building random forest combines the random forest combines multiple decision tree as we said, uh, and which increases its robustness, accuracy, and risk of overfitting. By reducing the risk of overfitting, we have already improved the accuracy of our model. That's it for today, guys. Thank you. I hope you understand all topics. I request you to execute each command or copy my code one by one and execute each command for better understanding of the code. Thank you.